Hi, in this section we're going to do addition and subtraction of matrices. And so we'll look at what a matrix is and then also some operations that we can do with this. So first of all, we want to be able to write values into a matrix, terminology of matrices, and how to add or subtract two matrices. That's our goals for today. So first of all, a matrix. What is a matrix? It's a rectangular array of numbers enclosed in brackets. So if we look down below here, this is an example of a matrix. And then if we have elements or a component, what is that? Well, that's an individual entry in a matrix. And so each one of these elements, so for instance, this 1216 is an element. 109 is an element. Then we also have something that's called a dimension. The dimension of a matrix is the number of rows by the number of columns. So if I go down here again, this would be 3 rows and then 4 columns. That's the dimension, 3 by 4. And then we have a row matrix, which is a 1 by n matrix. You need to be writing this down. And then we also have a column matrix, which is vertical. So what happens down here is that a row matrix would just be this, and a column matrix would just be this. Rows go across, columns go up and down. And then a symmetric matrix, it remains the same when the rows and columns are interchanged, and then a zero matrix when all elements are 0. So our first thing is to take a table and we're going to write it into a matrix. So what's going to happen is that we're going to take these values, so this would be 3 rows, and then we got 4 columns going across, and we want to put it into a matrix. So I'm going to start writing that. So that would be the first column. Continue on and write the other column. So this is our matrix that we set up. Now down here, we want to identify row and columns. And so when we do that, what we're trying to do is figure out what is the 2, 3. Well, when we write that, that would be the row 2 and then column 3. So we can call each item by these numbers. So if I go to row 2, then I go to column 3. This right here would be my A23. That's the one that I'm looking for. So when I look at this, A23 is going to be 0.89. Try these other ones and see if you can identify them. Pause this and I'll write them out. So A13, this would be first row and then third item. So this would be my A13. And then so on, we got the A22. And then we have the A31, which would be this one right here. Okay, so those are the values that we have. What is the first row matrix? So if we start talking about row matrices, this would be a row matrix. So this is a row. That would be the first row matrix. The second row matrix would be this. Third row matrix would be this. So you can break these out. So if you just wanted to talk about pizza, that would be this row matrix. If you just wanted to talk about VINs, VINs would be this column matrix right here. And so you can do each one of those. So those would be rows and columns. If we want to move on to adding and subtracting matrices, in order to add and subtract matrices, they have to have the same dimension. So if I look at this, this is your pizza matrix with the other items, and then this would be your sales tax service charge. This is 15% of each one of these respectively. So all I did was I took this number and multiplied it by 0.15 to get that number, and so on for the whole matrix. So all I do is, if I want to add these, this right here is the tax for this item. A11 plus T11 would give me the value, or how much that pizza would cost. If I go to the next pizza shop, this one with this tax, and so on. So all the elements just match up. So if we want to add A plus T, it has to have the same exact dimensions. So when I'm going to add these two, I'm going to take 12.16 plus 1.82. That would be the first item. then we'd have 1.15 plus, that would be 0.17. And then we continue this on for all of these values as we go on, and that would be our matrix. And I'm going to write this one out here in a minute. So check your values with mine and see if I got that right. A lot of little carry in there. I'm trying to do this in a hurry. Apologize if I get something wrong, but I think I'm good. So we just take each respective element, add them together. Then we have, we want to identify a symmetric matrix. The symmetric matrix means that if I have a row element here, so this would be a 2, 1, it's the same thing as a 1, 2, and so on. So if you look across what we call the main diagonal, this right here is the main diagonal. And if I do symmetry across that, that would mean that I would have a symmetric matrix. And so it's symmetry across the main diagonal. This right here is the main diagonal. And then here we have symmetry and so on. Symmetry on both sides. And so if we switched the two, switched the rows and columns, we would have exactly the same matrix. That only happens if it is symmetrical. Okay? Then a zero matrix. If I take this R and I add 0 to it, well, I'm just going to end up with R again. The zero matrix has to be the same dimension as what I have here. So really, for this one, the zero matrix would be a 4 by 4 of all zeros. Okay? So if I take and add zeros to all of this, I'm just going to get the same exact thing back. If I subtract R minus R, you can guess what I'm going to get there. I'm going to write these out. So R plus the zero matrix, and it's going to be the same dimension as whatever dimension you're dealing with, will just give you R back again. And if you go R minus R, you're going to end up with the zero matrix. Okay, so you just need to know what that is. All right, and once you get into the homework, some of the stuff will become more self-evident. But as you can see, many things can be written into a matrix. When you see a table in a newspaper, spreadsheets, etc., they all can be written into a matrix. So here is your homework. I hope you enjoy this. I really enjoy what we're going to get into in this chapter. Thanks very much.